quantum numbers, they were discovered by Schrodinger, and he has a very big contribution in for the discovery of atom. Why? Because he actually took into consideration the wave nature of the electron, right? That is why wave nature of the electron. That is why he gave he for this he gave a wave function, that is psi, which tells us the is about the electron, and psi square, it tells us about the psi is actually wave function. What is psi? Psi is actually a wave function, and psi square is probability of finding the electron in an atom, like probability of finding electron. So what happens is psi is actually wave function, psi square is probability of finding electron. So what happens, beta? Like we know that we have three axes. We have x-axis, we have y-axis, we have x, y, x, z-axis. We have three axes. So we know that if we have three axes, so electron can be present on any of the axes. So we can actually we can get to know about the psi square will tell us the probability of finding an electron, right? So see, you don't have to actually know the equation. I can tell you the equation, but see, let's not go into the depth. You just have to see he has given us on solving the wave equation or Schrodinger equation. He got three quantum numbers, that is n, l, m, which tells the address of the electron, which tells us the address. Like our main aim was to know the location of the electron. And we have one more quantum number, spin quantum number. It will tell like how the orientation of electron. We'll discuss about this in later video. So basically quantum numbers, these four quantum numbers actually tell us the location of an electron inside the atom, and the most important are n, m, right? So electron is basically, it acts as a electron. He had considered the nature of electron as a wave, and electron, like position of electron, we have to find the position of electron inside the orbitals, right, beta? And psi square tells us the probability of finding the electron. So now we have four quantum numbers, and the first is principal quantum number, which is denoted by n, which tells us about the size of the orbital, or we can say shell number. It tells us about the size of the orbital or shell number. For example, we have n equals to 1, 2, 3, 4, 5, and so on. So K shell, L, M, N. You must have studied about this in your junior classes also, right? Shell number based on the value of n. And we also know energy minus 13.6 z square upon n square. So as the value of n increases, the energy, it decreases, right, beta? So this is all about L. L tells us about the size of the orbital and shell number. Clear, bache? So as the value of n increases, what happens? The energy decreases. Next we have azimuthal quantum number, which is denoted by small l. Azimuthal quantum number tells us about the shape of the orbital. Principal quantum number, it tells us about the size of the orbital. Shell number, it tells us about the shape of orbital. What is the shape of orbital? I'll tell you, right? Or you can say it tells us about the subshell. Inside the shell we have subshell, and we can say it as shape of the orbital. So see what happens, bache. Here, suppose we have L values, then name, and what will be the shape. So beta, what happens? 0, 1, 2, 3. So we have, when L equals to 0, we have S orbital, and S orbital, beta, is spherical. What is the shape of S orbital? It's spherical. P orbital, L equals to 1, we have P. P is dumbbell. Right. Like suppose this is px in x-axis, py, and this is pz. We have sp, d, and then we have f. So f is, this is double dumbbell, d is double dumbbell, and this is f has complicated shape. So if I talk about the shape of d, it's like this, double dumbbell, like this, right? But you don't have to remember the shapes. You just have to remember that L equals to 0, s orbital, 1 p orbital, 2 d orbital, 3 f orbital, 4 g orbital. So you just the main three important for you is SPD. Even f also, f is also important. SPDF. These four are enough. Next we have beta. See beta, what happens? L is L. What is L? We have L, value of L is 0 to n minus 1. Right. Other words, n minus 1 to 0. Suppose we have L is n is 1, L is 0, n is 2, L is 0 to n minus 1, 0, 1, 3, 0, 1, 0, 1, 2, 4, 0, 1, 2, 3. L is 0. We have 1s. 1s is 2p. L is 1, 2p. 3s, 3p, 3e. Similarly, 4, 0 means 4s. 4, 1, 4p. 4, 2, 4d. 4, 3, 4f. This is how we have to determine, right, beta? And we can, all number of subshells equals to, right, beta? Next we have to see orbital angular momentum. Orbital angular momentum, L is equals to, the formula is h upon 2 pi under root of L into L plus 1. L is, what is L? Azimuthal quantum number. Angular momentum, suppose in exam they ask you angular momentum of an electron. So its formula is and h upon 2 pi under root of L into L plus 1. Right, beta? Can you do it? Okay. Next is find the orbital angular momentum for electron 3p and 2s. Beta, for 3p we know that the value of L is 1 and 2s the value of L is 0. We have just studied angular momentum, h upon 2 pi under root of L into L plus 1. So the answer is 2 root 2h upon 2 pi. Or if I can try to cancel root 2 by 2, what happens? I'll get root 2 here. So h upon root 2 pi. Yes, because we know root 2 into root 2 is equals to 2. Simple maths. And if we have L is equals to 1, 0, what happens? We'll have h upon 2 pi under root of L, 0 into 1. So it will become 0. Yes, bache? Next we have beta magnetic quantum number. We have magnetic quantum number which is denoted by m, small m, right? It tells the orientation of an electron. It tells us about the orientation of an electron. How? I'll tell you, explain. And the value of m is, minus L to plus L. It is from minus L to plus L. Just simplest way of writing. And n can be an integer, right? For example, we have L 0, 1, 2, 3. Name. What is the name? Just study S, P, D, F. Beta, yes. M. M is, values of M is minus L to plus L. L is 0, 0. Minus 1, 0, plus 1. Minus 2, minus 1, 0, plus 1, plus 2. Right, beta? This is plus 2. We have minus 3, minus 2, minus 1, 0. Plus, this is how we have to do it. Okay, bache? Clear? Now suppose I have, see, a formula is number of orbitals in a given subshell. Number of orbitals, you are asked in exam find out in a given subshell. I'm talking about shell, subshell. Its formula, which is number of orbitals in given subshell is 2 into twice of L plus 1. Right, beta? Suppose we have values of N, N and M. N is 1, L is 0, so M is also 0. So we have 1 S, 2, 0, 1. So 0 minus 1, 0 plus 1. So we have 2S and 2P, 3. We have 0, 1 and 2. So 0, 0 minus 1, 0 plus 1. We have minus 2, minus 1, 0 plus 1 plus 2, right? So we have 3S, 3P, 3D. So rest you can try by yourself. For 4 and 5 you can do by yourself. Values for values of N equals to 4 and 5, you can simply find out the value of N and M, and also like what is the name of the orbital, like 3, 4S, 4P, 4D, right? Now let us try some questions. How many shells and orbitals are present in a shell for N is equals to 3 and N is equals to 2? But what happens is, how many subshells and orbitals, right? The formula for subshells is number of subshells is always equals to beta N. Number of subshells is always equal to shell number, you can say it's always equals to N. And number of orbitals in a shell is equals to formula in a shell and N square. If they ask you in a subshell, it will be 2L plus 1. We have just discussed. In a subshell is 2L plus 1, 2 into L plus 1. Beta it is, wait, just a minute also. It's actually not, its bracket will not come here. It's 2. Beta it's 2 into L plus 1, right? Let's see. The value is 2 into L plus 1. Right, here we have N square. N square. So number of subshells, right, beta? But N is equals to 3 and N is equals to 2. The number of subshells will remain. For here it is 3, it will be 2. And number of orbitals, 3 square, that is 9, and here 2 square, that is 4. This is how we have to do this questions. Next, we will definitely solve more questions in the upcoming lecture. Now let us discuss about the fourth quantum number, which is spin quantum number. Now beta, in case of spin quantum number, what happens? It's denoted by S, and it tells us, we know that electron, it rotates about its own axis. The electron rotates about its own axis, and we know that the value of S is either plus half or minus half. See what happens. Since the electron is rotating about its own axis, so it can rotate like this, either like this or like this. The electron can rotate in two ways, either plus half or minus half. Either it can be clockwise or anti-clockwise, or it can be, if it's clockwise, it's anti-clockwise. If it's anti-clockwise, it's clockwise, right beta? So it will depend. Suppose like we are filling an electron. So one electron is, if this is clockwise, this is anti-clockwise. This is clockwise, this is also clockwise, or this is anti-clockwise, this is also anti-clockwise. This is anti-clockwise, so this is clockwise. So it's just that how, like spin quantum number tells us like how the electron is, like where the electron is moving, whether it's clockwise or anti-clockwise. We have to assume it by our own self, right? Now bache, see what happens is, now these are, here we finish 4 quantum numbers, that is principal quantum number, right? Second is azimuthal principal quantum number, which tells us about the number of shells, right, and the size of the orbital. The second is the azimuthal quantum numbers, which tells us about the shape of the orbital. Third is the magnetic quantum number, which tells us about the orbit orientation of the orbit. And fourth is the spin quantum number, which tells us about the electron, how is it revolving, how it's rotating, how it's about on axis. Clear, bache? Next we have Pauli's exclusion principle. Based on the fourth quantum number, we have Pauli's exclusion principle. It says no two electrons in the same atom, no two electrons in the same atom can have same set of four quantum numbers. Means two electrons in same atom can never have the same set of four. Like suppose if two electrons, they have the same values of n, n, and m. So they will never have the same value for s. One will have the value plus half and the other has to have the value minus half. Right? It's not possible that the both will have the same values. Right, beta? Only, or in other words, we can say only two electrons with opposite spin can be, suppose this is an orbital, only two electrons with opposite spin can be present. Like two electrons can never be filled in an orbital with the same spin. This is not possible. This is not possible. Either this is possible or this first one is in downward and second is upward. This is also possible. But both are upward or both are downward. Never ever possible. So this is Pauli's exclusion principle. Now let us try some questions based on what we have learned till now. Find the number of electrons in the second shell. Second shell where n is equals to 2. So number of electrons. See if I talk about number of orbitals, we have just learned the formula. Number of orbitals is equals to, in a shell is equals to n square, because they're asking about in a shell. Number of orbitals in a shell, beta, it's equals to n square, so which is 2 to the 4. But, and we know that in one orbital, how many electrons do we have? 2 electrons in one orbital. We have 2 electrons. So therefore, total number of electrons will be number of orbitals, that is 4 into 2, which is 8. So we have total number of electrons are 8. Right? So if somebody asks you formula, number of electrons in a shell is equals to 2n square. Rather than remembering so many formulas, it's better that you remember this one formula of number of orbitals, and for whenever an examiner asks you to find the number of electrons, so simply multiply number of orbitals in a shell with 2. Right? So we have, again I'm writing it, number of orbitals in a shell. What is the formula? N square. If somebody asks you number of electrons in a shell, simply multiply because you know that in one orbital we have 2 electrons, so in n square we have 2n square. Again, number of orbitals in a subshell. How many orbitals do we have inside a subshell? We have 12 plus 1. So number of electrons will be twice of 12 plus 1, or they can also give you like this, 4l plus, right, bache? Okay, next we have number of electrons in fourth shell. We have for n is equals to 4. What happens here is number of electrons in fourth shell for n is equals to 4. Now electrons, orbitals, simply calculate orbitals first. In a shell, number of orbitals in a shell is n square, that is 4 to the 16. Therefore, number electrons will be 2 into 16, which is nothing but it comes out to be 32. I hope this much is clear to you, right? Next, number of electrons. Now they are trying to fix the condition. For example, they are saying n is equals to 4, m is 0, and s is plus half. Find the number of electrons in this case. Now n is 4, n, l, n. N is 4, L is, what will be the value of L? 0, 1, 2, 3. Here M, L equals to 0, M 0. L equals to 1, L minus L2 plus L. 0 plus 1 minus 2 minus 1. 0 plus 1 plus 2. Similarly, here also we have minus 3 minus 2 minus 1, 0 plus 1 plus 2 and plus 3. Now here, since we know that in an orbital we can fit 2 electrons, but here they have fixed the spin 1 electron. Here also only one electron. There are 5, they have only 1 electron. Similarly for D also, F also we have 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 plus 7. 9 plus 7 is 4 electron. Can you do it by yourself? Right? Total number of electrons, if you find, it will be 32. But actually they have said that the spin is only half. So you have to only consider either this or this. We cannot consider both. Yes, but so that is why it's 16 electrons. You can try it at home. Just try to draw these by your own self. Right? Next we have number of electrons for n equals to 3. N, L, M. N is 3. We have L 0, 1 and 2. And it's a similar question, right? M is 0, minus 1, 0, plus 1, minus 2, minus 1, 0, plus 1, plus 2. Again, we know that in one orbital we have 2 electrons, but here only one possibility is 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 is the correct answer. How? Because simply just draw the, and we know that since P has 3 orbitals and we can fill like this. We want to fill P orbital, we can fill like this 1, 2, 3, 4, 5, 6. Here we can fill 2, here we can fill 2, here we can fill 6. And in case of D, we have 5 orbitals. So here we can fill 10. But here they have fixed that S is only half plus half. So we can only fill single electron. So therefore we have only 9 electrons for this. Right? Next, find the number of electrons for which N is 3 and it is mod M is 1. Means M can be plus 1, also M can be minus 1. N is equals to 3, L will be 0, 1, 2, M 0, not possible, minus 1, 0, plus 1, minus 2, minus 1, 0, plus 1 and plus 2. Right, beta? So this minus 1 is possible, plus 1 is possible. This is not possible. This is not possible, minus 2. This is possible, and this is not possible. We have 1, 2, 3, 4 orbitals. We have 4 orbitals, and we know that in each orbital, how many electrons can we fill? We can fill 2 electrons each. So total number of electrons will be, right, beta?